This is the session where we'll talk a little bit about development geology and geophysics. A lot of what we do in the development stage is similar to exploration. The tools and methods and techniques that I've been talking about that have been more exploration focused can also be modified for development and production. So the title slide here, I show the time period of a resource or a field early on, kind of midlife and late in life. And we begin with exploration. Then as we make a discovery and delineate this discovery, we move into development geology and geophysics, trying to understand if we are going to make money off of a field if we develop it, which another way of saying that is it worth investing to put in the equipment and resources and people and time to get the field to where it is producing oil and gas. And then the final stage would be the production stage. And on the bottom, I indicate the scale of analysis. Early on, when we're trying to figure out where we might want to be exploring and working towards developing fields, we're more at a regional scale. We transition into a block-wide scale, then a prospect level, then the reservoir scale, and in production, we could get down into individual field compartments, the different units that would flow the hydrocarbons. So as I mentioned, we have an assets life cycle. I talked about this in an earlier lecture. First, we have to capture opportunities. That's primarily through lease sales. Then we discover hydrocarbons by drilling wildcat wells. We decide whether or not it's worth while to develop the field, to initiate production, and then we're going to deplete the field. And so the capture and discovery, that's what we do in exploration. The earliest phase is called new ventures, where we're deciding which parts of the world we want to be active in. Exploration is trying to figure out where some undiscovered hydrocarbons lie. Then we get into development and finally into production. And so today we'll talk about some of the things that is done in the development phase in terms of geology and geophysics. So I've already talked about this. We're going to focus in on development, where maybe we're working on a reservoir scale of focus. The bottom shows information and effort. As the information on the field develops, the effort and information increases both on the geoscience side and on production and engineering side. For the geosciences in particular, most of the effort is geoscience in the early stages, not so much in the engineering realm. But as a field is discovered and delineated and put into production, the geoscience effort tends to taper off a little bit. We have more people working production geology and engineering. So just to review, the phase one is to capture the opportunities. We want to recognize hydrocarbon potential and capture acreage. We're looking basin-wide as our focus of analysis, looking at local wells and seismic. Maybe we have some adjacent wells, some analog areas. We worry about the tectonic setting. I'm in a extensional pull-apart basin or a compressional or strike slip. If we have wells in the area, we'll tie that to the seismic. We'll build a first pass gross structural framework and also a stratigraphic framework. The products at this stage is to try to develop a series of play adequacy maps, looking at things like source, reservoir, trap, seal, and migration. We'll identify some leads, things that are interesting in terms of possible potential to be economic fields. We'll do a preliminary assessment of how much oil or gas might be there, and if we think it would be economic to try to pursue it. We would risk and rank the different leads, and then based on how much potential we think an area has, we would develop a bidding strategy and try to capture some acreage. The second phase, discover hydrocarbons. We're looking more at a block scale analysis. We would have denser coverage of 2D seismic, or we may have a 3D seismic volume for the block or blocks that we have a right to explore within. We would refine our well seismic ties and our faults and our horizons, refine our interpretation of the environments of deposition, refine our geochemical models. We would look for direct hydrocarbon indicators or indicators that we have amplitude versus offset that could tell us something about the hydrocarbon presence. And we'd have to do time to depth conversion. So we would screen our initial leads, develop and mature prospects, assess how much a prospect might be worth in terms of volumes of oil and gas. Again, risking and ranking of the prospects that we might have in our area, and then propose one or more wildcat wells to try to verify that we do have some economic oil fields or gas fields. And whenever we drill the wildcats, we're going to have a post-drill evaluation looking at the results compared to what our predictions were and how that might either be favorable or unfavorable in terms of an economic quantity of oil and gas. Let's say we drill a wildcat and we discover what we think is a significant amount of hydrocarbon. We may need enhanced seismic data in order to decide whether or not to produce the field and how to, what the plan would be to do that field development. We might drill some extra wells, and then we have to tie those wells to the seismic. Our mapping becomes more important and more detailed and more focused on our reservoir interval. We can calibrate our seismic attributes, especially if we have several wells. We can do some seismic modeling to try to verify that our interpretations are correct. And we may build a geological model so that we can do some reservoir flow simulation. Our products at the development stage, we would have more detailed information on the reservoir architecture. We may develop a reservoir simulation model to try to understand how the field might produce over its life expectancy. That might be 25 years, might be 50 years. We would come up with an initial development plan, figure out how much funding that would be, and see if we can convince management that it's worth funding our project. We would start production from some of the wells. We would hope for an early start of oil or gas. And as we gain more information, we may have to revise our models or our plans. So here's an example, hypothetical one. I've shown this before. We have a gas cap and an oil leg. We proposed drilling a wildcat well here. We made a discovery. There's a fault separating the northern part of the anticline. And so in the exploration department, we may drill an additional well. Some people call those confirmation wells. Other companies refer to them as field delineation wells. And we want to firm up the notion that this is indeed an economically viable field. We're worried about the area, thickness, and the volume of the reservoir, what's some of the details of its internal architecture are, and how it might be broken into separate compartments. So on the left here is what we might expect to see at the end of the exploration phase. In the field development phase, we'll drill some additional wells. There was a well in this hypothetical case drilled to the west, primarily to test how reservoir properties might be changing as we go to the west side of this anticline. Those properties might be the same, they might be improved, they might be less favorable. You can also see there's more detail on the faults, and we have a separate little segment here or compartment. We're not sure without drilling a well how that might add reserves. Is there enough oil indicated by the green in this compartment that it would be worth trying to develop this particular component or compartment of the field? And so a development well was drilled in that location. We may find that the data that we were using for exploration isn't quite adequate to answer all of our field development questions. And so we may need to improve our seismic data. And the easier way is to reprocess the older data and take advantage of some of the improvements in imaging that have occurred over the years, or maybe just increase the budget and apply more expensive but more rigorous algorithms to get us better images. The other option is to reshoot the data in the case where the old data just can't be improved through reprocessing. If we shoot new data, that may be 2 or 3 years before we can shoot it, get it processed, and get it into the hands of the interpreter. So there's also a time element as well as a dollar constraint on our acquiring new data. We've been using Barracuda in the Gippsland Basin offshore Australia for a lot of our exercises. In this case, the Barracuda 1 well was drilled at this location. The hotter colors are the crest of an anticline. We drilled near the crest. It was a sub-unconformity trap. The work was done on poor quality 2D seismic data. When they drilled the well, they were fortunate enough to find a 100-meter gas column and a 13-meter oil column. So that was promising enough that they decided to continue work in this area. And the company in our scenario acquired 3 blocks over this particular anticline, the Barracuda High. They had a lead. They matured that into a drillable prospect, something they were ready to go to management and say, we think we should spend the money to drill the Wildcat well. That well was drilled. It was successful. And still within the exploration phase, they drilled 4 additional wells to delineate the field, to confirm the size of the hydrocarbon volume, and ensure so that management was comfortable that, yes, we should proceed and build and install and operate an offshore platform. Another thing that might be done towards the end of the exploration phase, if a 3D seismic survey has not already been acquired in the area, they may want to design, approve, acquire, and process the 3D seismic so that when they pass this over to the development geoscientist, they'll have the 3D survey, or it will be coming to them shortly. So after the exploration, they've drilled the Wildcat discovery well and 4 additional wells. The asset or the field, potential field, is passed to the development geoscientists. Normally, some of the explorationists that worked the field will transfer with the asset so that some knowledge and a person with that knowledge continues into the next phase, the development phase. I'm sorry, I got myself out of sync here. So normally an explorationist or 2 would follow the project into the production group or the production department or the production company. It depends on the size of your company. Much of my career was with ExxonMobil. ExxonMobil has an exploration company, a development company, and a production company. A smaller company might have departments, one exploration department, another field development department. So let's continue our story with Barracuda field, and that's what we'll do with the rest of this lecture. And then next Thursday, we'll talk about production geoscience. So if you are doing the exercises, exercise 30B, you're given this map, and time in milliseconds is how thick the reservoir is. So the areas that are in dark gray, we're outside the extent of the hydrocarbon. So the gray to blue boundary is where we have the hydrocarbon water contact. In case of Barracuda, it's primarily gas to water, although there is a 13-meter thick oil column. The discovery well was drilled at this location. And so the question that you're asked to think about and try to solve in exercise 30B is if you were allowed to drill a couple of field delineation wells or confirmation wells, where would you locate those so that you got the maximum amount of information? So giving you a little hint, we would like probably to understand the southwest portion of the field. There's a fault that cuts through here, which causes some of the blue colors to kind of leak across. And so is this segment of the field similar to this segment, or is it different? One of the questions is the gas water contact at the same depth in the southwest corner across this fault as it is to the northeast? You probably would also want to sample the field where it's thickest, and maybe you want to get another confirmation delineation well towards the northeast to see how reservoir properties might change over the length of the field. And I'll notice or point out at the bottom, this scale bar is 8 kilometers in length. So in the case of Barracuda, they had the discovery well, the Barracuda 1. They drilled 4 additional wells. The Barracuda number 2 is kind of buried in here. Barracuda 3 did sample the southwest corner. Barracuda 4 was positioned here, and Barracuda 5 was positioned at this location. So we now have 5 wells, and each of those wells, this is the Barracuda 1, we can generate a synthetic or modeled trace, which is the red wiggle here. We can compare it to the actual seismic that goes through the well, the black and white wiggles. And we have a number of either formation tops or seismic horizons that were correlated around. And we can use the well seismic tie method to try to understand where on the seismic trace should the top of Latrobe or the top of the coarse clastics or the gold sequence boundary or the pink sequence, the magenta cobalt sequence boundary be marked and then mapped around. So in the exercise, you're given a transect. Let me go back up 2 slides. So transect A to A prime. So I have the eastern part on the next slide, which has the Barracuda 5, the Barracuda 4, and the Barracuda 1 well. And so your task in the exercise is to make well seismic ties for these 5 with about 8 horizons, and then see if you can correlate on this zigzag line connecting up the different wells and make sense out of the reservoir stratigraphy. So I'll talk more about that next Tuesday as we do the next lecture. And one thing I would point out that the Barracuda 5 well is not a perfectly vertical well. It does have a little bit of deviation. And so this display shows you that we can display the modeled or synthetic trace even if the wellbore is not totally vertical. So that's the prepared statements for today. And as I said, a lot of the material that we've already talked about for more of the exploration phase can also be used in the field development stage to answer some of those questions about, is there enough hydrocarbon here that it would be economic to develop the field. So next Tuesday, I'll talk about detailed stratigraphy. We'll use the Barracuda field as an example. And then next Thursday, a week from today, we'll conclude. We'll have two sessions, one at 2 o'clock Eastern Standard Time. We'll go off of daylight savings this weekend. We'll talk about production geology and geophysics, and then kind of different topic, how we write reports in industry and how that might differ from how you write scientific papers within academia as grad students. So I will turn the discussion leadership back over to Dr. Sumi and see if there are questions either about today's material or something that we have covered in the past.
Thank you, Fred. We have a question from Patrick Taylor who asks, is the DHT the Donovan magnetic anomalies and or the electromagnetic methods?
Could you repeat that for me once again?
Sure, and I'll put it in the chat box too. Let me just handle that really quickly. The question was, is the DHT the Donovan magnetic anomalies and or the electromagnetic methods?
I am not familiar with those, so I will just have to claim ignorance and apologize for not being familiar with DHT.
Okay, great. So that was our only question. If there's any additional ones, please feel free to write them in as we are concluding. But thank you so much, Fred. And as you mentioned, we will be wrapping up next week on November 7th and on November 9th. So see you all next week. All right, take care, everyone. Bye.
Okay, thanks, everyone. Have a great afternoon.
Great. Bye.
Bye-bye.